Welcome to the today's class. Today we'll discuss about the block diagram of 8086. So this is the block diagram of 8086. The complete block diagram of 8086 is divided into two parts. One is the bus interfacing unit and another is execution unit. So this part is the bus interface unit, whatever is being shown in the dotted lines, and the bottom dotted lines, whatever is being shown in the bottom side, is the execution unit. So the name itself is saying the bus interface unit, which is acting as interfacing between the external world and the execution unit. So whatever execution unit need to execute, so will be forwarded by the bus interface unit to the execution unit by getting that information from the external world. So for this, the bus interface unit is having 6-byte instruction queue in 8086, whereas in 8088 the instruction queue size is of only 4 bytes. So that is one difference, architectural difference between 8086 and 8088. So the remaining internal architecture is almost same for both. So it can fetch 6-byte instruction queue. This queue can have 6 bytes of instructions prefetched and stored in this queue. That is the usage of the queue. So prefetching is done with this, and it has, so bus interface unit is having one calculation unit, so which is physical address calculation unit. So what this unit is going to do is, so if it has to fetch the next instruction from the memory, then it is going to calculate the address of the next instruction. So the next instruction address is equal to 10H into code segment content plus content of the instruction pointer. So this will give us the address for the next instruction. So this address calculation unit, what it does is, it will get the contents from the code segment register and it is shifted left by 4 bits, which is equal to multiplication of 10H, and the contents of the instruction pointer will be added to this. Then resultant what we are going to get is a 20-bit address. That 20-bit address will be sending to the memory, then memory will supply the next instruction. That next instruction is stored in the instruction queue. So that is what the calculation of the next instruction address. And if data is to be read from the memory, then the address of the memory for data will be calculated. So that is equal to data, address for data is calculated with 10H into content of the data segment plus either SIR, DIR, BP, any other register content. Now this will give the 20-bit address for the data which is present in the memory. Then that data will be read from the memory and it is going to be used for the performing operation. So that is how the address calculation is going to calculate the address of the memory for either for instruction or data. Even if you want to store something onto the top of the stack, that is push operation, or if you want to get the data from the top of the stack, that is pop operation, for that also stack address, then even that is also, that is the stack address is calculated as 10H into stack segment content plus the content of the stack pointer. So with this, it can calculate the address of the stack area, then 20-bit address of the stack area will be calculated with this. Then using, if it is a push operation, then the specified register content will be stored on the top of the stack. Address is calculated with this. If it is a pop operation, then the content from the top of the stack, the address given by this, is being retrieved and it is being stored in the specified register as a destination. So this is what the address calculation unit is going to do for calculating the memory address, 20-bit memory address. So from taking the inputs from two different registers, one is from the segment register and other is from pointer or index register. That is how the address calculation unit. Apart from this, other registers present in the bus interface unit are extra segment, code segment, stack segment, data segment and instruction pointer. So now, we have used code segment and instruction pointer for calculating the address of the, that is, this is the code segment register and this is the instruction pointer. These two are used for calculating the address of the next instruction, and we have used the stack segment, data segment and source index or destination index or base pointer for calculating the address of the memory where data is available. And for the stack, so this is the stack segment and the stack pointer which is present at this. Okay, these contents will be used for calculating the 20-bit memory address for either reading the data from the memory or reading the next instruction from the memory or retrieving the contents from the top of the stack or storing the content into the top of the stack. So for any of these operations, so it is how it is being used. So this is the fundamental role of bus interface unit, especially it is used as interfacing between the external world and the execution unit part. Next comes to the execution unit. So in this we have four general purpose registers, AX, BX, CX, DX, where AX is further divided to two 8-bit registers AH and AL, BX is divided to BH, BL, CX is divided into CX and CH and CL, DX is divided into DH and DL. So for general purpose data storage, either 8-bit storage or 16-bit storage. If it is 16-bit, then AX or BX or CX or DX. 8-bit, any one of that, either higher order byte or lower order byte, depending on the requirement. Along with that, other four registers present in the stack pointer, base pointer, source index, destination index. So base pointer, source index, destination index will hold the offset address of the memory where data can be retrieved or stored with the help of this offset address from these registers, along with the either data segment or extra segment register contents. Okay, that is the use of these registers. Anyway, we have already discussed the functions of the special functions of the general purpose register in the previous class. Just remember that. Next comes to the control unit part. So this control unit is going to read one after the other instructions from the queue, and those instructions will be decoded. Upon decoding of the instruction, then the control unit is going to issue the required control signals to either address calculation unit, so that it can calculate the address of the maybe operand address, so that operation will be performed on that data. Okay, so if it is, and it is going to issue the control signals to the ALU to perform the required arithmetic or logical or shift operations. So depending on any of the operation, then it may be issuing the control signal to the ALU, control signal to the registers involved in the operation, so that the registers can supply the inputs, and the ALU is going to perform the operation. After performing the operation, whatever result is being produced, the result can be stored back into one of the registers, okay, for next operation purpose, or from the register it may be stored into the memory, or it may be sent to IO devices. That is, so after producing the result, and immediately after producing the result, based on the status of the result, then flags will be updated. So the corresponding flags will be updated based on the status of the result. If the result what we are going to get is a 0, then 0 flag is updated. If the result is non-zero, then based on that non-zero, whether it is positive or negative, sign flag will be updated. Whether the result is having even number of ones or odd, based on that parity flag is updated. Whether if it is addition or subtraction operation, arithmetic operations, whether there is a carry from MSB during the addition or borrow into MSB, during the subtraction. Based on that, carry flag. So likewise, the flags will be updated in this. So that is the basic operation of the 8086. So the bus interfacing unit is going to react or act or interact with the external world by calculating the required address depending on the requirement, and the execution unit is going to perform the required operations by getting the instructions from the instruction queue and decoding them, and after decoding according to the operation to be performed, the control unit is going to issue the required control signals to all the functional blocks. Then accordingly the functional blocks is going to perform the operations. So this is what the basic fundamental functionality of the 8086 processor. So today I'll stop at this point. Thank you all.